This is Geometry A, Unit 4, Lesson 3. We are going to prove lines parallel. First, a couple of things that we need to remind ourselves of. A conditional statement is an if-then statement. Let me give you an example. Conditional statement, example. If I have a Dalmatian, then I have a dog. Okay? If I have a Dalmatian, then I have a dog. The if part of the statement, if part is called the hypothesis. The then part is called the conclusion. If I say Dalmatian is A and dog is B, this can be written A implies B. Okay, that's a conditional statement. Need an L. Okay. The converse of a conditional statement is when you switch the arguments. Okay, if I have a dog, then I have a Dalmatian. Okay, notice this has been switched. Hypothesis and conclusion, and now is B implies A. And you'll note that they're not the same statement. If I have a Dalmatian, then I have a dog happens to be a true statement because all Dalmatians are dogs. But if I have a dog, then I have a Dalmatian is a false statement because there are many dogs that are not Dalmatians. An example would be a German Shepherd. That would be our counter example. Okay? But there are statements that are reversible. There are some statements that are reversible, and we call those biconditionals, things that work both forwards and backwards. In our last lesson, you may recall, we learned if L is parallel to M, if lines are parallel, if two lines are parallel and they're crossed by a transversal, then we learned corresponding angles are congruent. We learned alternate interior angles. Are congruent. We learned alternate exterior angles. Are congruent. The first is the corresponding angle postulate. The second is the alternate interior angle theorem. The third is the alternate exterior angle theorem. We also learned that same side interior angles, same side interior angles are supplementary. And we also learned that same side exterior angles are supplementary. That's supplementary meaning adding to 180 degrees. Okay, that is all built on or contingent upon whether or not the lines are parallel. If the lines are parallel, all 5 of these facts are true. Now, it just so happens the converse of those statements is also true. So the converse says, if corresponding angles are congruent, the lines are parallel. If alternate interior angles are congruent, the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. If the same side interior angles are supplementary, then the lines are parallel. And if the same side exterior angles are supplementary, the lines are parallel. Those are also true. So we would state, if I want to use one of these rules, the converse of the corresponding angle postulate says, if corresponding angles are congruent, then lines are parallel. So we can use the converse of each of these statements to prove that lines are parallel. Let me give you an example. Okay, and you've got to use the word converse. The alternate interior angle theorem says alternate interior angles are congruent. If lines are parallel, alternate interior angles are congruent. If I want to prove lines parallel, I must cite the converse of the alternate interior angle theorem, which says if alternate interior angles are congruent, then the lines are parallel. So here's our sample proof here. Okay. We're going to have two lines crossed by a transversal. Okay, let's call them L and M and T. L, M, and T. Okay. And let's say angle 1 is here, and angle 2 is here. Let's go with this one here. All right? Okay, angle 2 is here. Okay, and I want to prove, so given, here's our given. Given angle 1 is congruent to angle 2. Prove L is parallel to M. Okay, so the difference now is we don't start with L being parallel to M. We start with some angles being congruent or some angles being supplementary. Okay, now I could just immediately cite the alternate exterior angle converse the alternate exterior angle theorem. I'm going to go off of the corresponding angle postulate. So I'm going to name another angle 3. And as with all good proofs, we want to start statement. First statement needs to be the given. L is parallel to M. Reason or rule, I like rule better. Rule, what rule says L is parallel to M? We were given it. We were told it's true. So we're going to assume it's true. Okay, end with, always when writing a proof, have your goal in mind. Just like entering directions on a GPS, you need to know where you're going. We're going to say, oops, a given. We weren't given L is parallel to M. Forgive me. We were given angle 1 is congruent to angle 2. Some of you are probably screaming at the recording. Yeah, it's not right. Angle 1 is congruent to angle 2. Start with the given, angle 1 is congruent to angle 2. End with what we're trying to prove, L is parallel to M. Okay. I don't know what number that is, but that's where we're going. All right, so let's go there. All right, so angle 1 is congruent to angle 2 is where we start. So let's mark it on the page here. All right, so I might say step 2, angle 2 is congruent to angle 3. Okay, how do I know angle 2 is congruent to angle 3? Well, they are vertical angles, and there's a rule that says vertical angles are congruent. Now, by the way, if you just say vertical angles, you haven't said anything. You just named the kind of angle they are. You have to cite a rule, and the rule says vertical angles are congruent. So you can either state what the rule says, vertical angles are congruent, or you can name the rule that says it, the vertical angle theorem. Okay? So either vertical angles are congruent or vertical angle theorem. I'm going to say vertical angles are congruent. Okay, so 2 is congruent to 3. Now look at what we've got. 1 is congruent to 2, and 3 is congruent to 2. Therefore, 1 and 3 are both congruent to the same thing and must be congruent to each other. 3. So angle 1 is congruent to angle 3. And the reason two things congruent to the same thing are congruent to each other, that is the very definition of the transitive property of congruence, transitive property of congruence. And now we're ready for the last step. We have angles 1 and 3 congruent, and angles 1 and 3 happen to be corresponding angles. And we know if corresponding angles are congruent, the lines are parallel. So step 4, okay, we could state what the rule says. If corresponding angles are congruent, then the lines are parallel. Or we can name the theorem, and I prefer to name the theorem here. The name of this theorem is the converse of the corresponding angle postulate. Okay, and that's what we set out to prove. So quod erat demonstrandum, QED. I said it, therefore I proved it. Okay, so that's an example of a proof that lines are parallel. In this case, given a pair of congruent alternate exterior angles. So we just proved the converse of the alternate exterior angle theorem is basically what we did.